My name's Carl. I'm the current president of the Dallas Personal Robotics Group, and most names I recognize, some I don't. So I was thinking we could do what we did last week, which is to just kind of go through the list. Maybe everybody can give a minute or two, tell about themselves if they have a project going on. And then after that, we have lined up, Clay has a couple of, Clay's the current vice president, and Clay has a couple of topics to share. And then I have some show and tell to share, and then if anyone else has, we can do that as well. So people will continue to jump on, I think. But I guess having said that, should we? How can we proceed? Shall we run down the regulars list? So I've already introduced myself. Clay, would you like to give just a moment? Well, actually, why don't we hold off on you? So we'll save you towards last because you're going to present anyhow. So Doug, can you just a couple words about yourself, what you're working on in this?
All right. First of all, Murray, I was in February. I was about 18 miles away from your house. So I was in the capital, whatever the capital. Wellington, yeah. Yeah. We went all over New Zealand, so it was close. Almost gave you a call.
Oh, you've been well.
Here, Carl, put me on so I can see myself here.
Well, okay. So the way you can do that, if you're not familiar, maybe I'll share my screen and hopefully the controls will show. But basically, if you're not familiar with the Google Hangouts Meet, speak up if you can't see my screen. But the basic idea is that if you're presenting, it has this little bar you see at the bottom, and you can get that out of the way by hiding it. And you can mute your own microphone here by clicking that, or you can mute your video by clicking that. It actually can do captions as well. That's kind of cool. I'm going to leave those off. But then on the right-hand side, if you want to present, there's these three dots, and you can change what you're presenting and manage your settings. I'm presenting, so this is what it looks like when you're presenting. And then on the right-hand side, Doug, so if you'll notice up in the corner, I think you'll see this kind of like we have 10 people online now. So if you click on that, then you can pick which thing you want to have on your display. Okay. So pretty much anybody can choose to present whatever they want at any given time, and then you can look at whatever you want to look at just by clicking on that. So that's one little trick.
Inception, baby. We're going.
Yeah.
Okay.
And then another thing, by the way, is there is this chat. So real time, we can say hello, everybody. And that's right over here up in that same little area. So we can send links and stuff back and forth. So having said that, so Doug, just a moment or two, and what are you up to in the last week of quarantine?
Okay. Well, last week I was working on the Build More Robot series, but this week I finally got my Husky lens.
All right.
Okay, so it finally came in, and I was looking at it.
And that is for everybody, Doug, just sit a moment what it is.
Okay, this is made by DF Robot. It's actually in a little silicon case that they also sell. I got it on the original Kickstarter, and they threw in the case for free. But it's about $45, give or minus $5, and it's supposed to be. Think of it's an attempt to be a Pixie for AI. Okay, right. So where a Pixie was supposed to be a sensor that essentially did any kind of a blob sensing that you wanted to do, or that more of a OpenCV type thing. This is actually trying to be an AI. So it has built-in applications. So like if you remember in the Pixie, so you can do a blob detector basically. Well, in this one, you have face recognition, you have object recognition, you have line following, which is, I'm going to be testing that out to see what I can do with that. I know Ray's done some work with that already, but I'd like to see if I can get it to, I have a practice course, which is white on black and black on white. And I'd like to see if I can get it to actually do that course this week. So anyway, my new exciting toy for the week. We'll see how it goes. It has some other functions too, but basically it's like CAN programs, and it communicates with either I2C or serial port. It's supposed to be 200 times faster than some ST microchip that they're using as a comparison. So I don't know. I assume it's just that's just an ARM chip. That's pretty much it, Carl.
That's cool. Thanks.
Yeah.
So Harold, we're just going to work down the list here. What have you working on, Harold?
Well, I've been, I don't know, my client during the day has been taking around all my real time. Imagine that, trying to earn $1. But I've got a couple of things submitted that I've been planning, scaring the heck out of doing some ROS on Windows. And I've got the chassis built. Of course, you guys, some of you, Carl's seen it already. But I've got me a latte pad and a few other things lined up to go do that. And I believe it or not, I have now cleared the decks for a whole bunch of stuff that I might actually work on that project. Especially Carl knows that I do a lot of the Hackster.io stuff, and we've got to do one of these virtual meetups as well. The next time I thought we were going to do TinyML. Jonathan was going to kick that out. We had to postpone it this last time because this whole, hey, no big group meetings and things. And not that we have a big group, we have a big enough group.
Yeah.
And so we're gonna do some things like that and figure that out for our Hackster group and see what that's going on there as well. And so my actual real goal over here in probably the next 30-60 days is let's fire up enough of this robot so I can get a Bluetooth to the Windows box to have a control over USB, the motor controller, and have it run around and do things. Whether it goes in a straight line or circles itself into death, I don't really care. I just like to be able to make that work probably in the next, 30 to 60 days or something. That's kind of my goal.
With Ross, no less.
With Ross, no less. Yeah. So
yeah.
I may have bit off a big chew here, I think, because Ross is just not a one thing. It's a whole
framework with lots of
economy of things, if you want to call it there, right? Frameworks and visualizers and all that stuff. And so I submitted a couple of talks to a couple of places. Whether they're going to make it or not, I don't know. But I could be on the hook for that conference or KCDC. And the name of the talk is Industrial Strength Open Source Robotics with Windows or something along those lines. Because I mean, I'm not an expert at it, but I've seen some stuff on it, and everything I've read, we got people like Amazon and other folks like that using this inside their robots. It seems like something I should know or play with. And I know somebody in this group has done some of those things too, but it's been a little while since they're happening. Now we've got ROS 2.0, and it does different things, and it's supposed to be even more modular and things and that kind of stuff. So I don't know what all that means yet, but hopefully I will pretty soon.
That's cool. Yeah. Awesome. And by day, you're a Microsoft MVP, right? So
Microsoft MVP, and in that space, I'm looking to fire up something called Blazor, which is basically WebAssembly, which has been in your browser here for the last 3 years, believe it or not.
Yeah.
C# in the browser. You're coding C# directly in the browser doing things. It's actually kind of cool. And I'm trying to jump into deep into pool on that and do some fun stuff with that. So
cool. Thanks.
Yeah. Hey, thanks for calling it out, man.
Yeah.
Got my own horn.
No, that's one of the things that's cool about the group that we have is that we have guys with all kinds of experience, and If you don't know a particular topic in the DPRG, there's probably somebody who does that can help you out. So for those of you that are new to DPRG on the call, we like to trade up and share around what we know. So next in line, Jack, a word or two about yourself and how your college is going now that it's all remote.
I'm Jack, and I've been here for about 5 or 6 years with the club.
Old time.
Anyone who didn't know, and yeah, they've moved all of the college stuff online now, so I still have to do it, but it's pretty similar to how it always used to be. And right now, like I said last time, I'm working on the 6-can competition robot.
Yeah.
And got it here.
Wait a minute, are those LEDs I see?
Jack, the NeoPixel ring, are you presenting? Oh, we got a screenshot, then it froze. Oh, there we go.
I'm using that so that I can see what the LiDAR sensor is thinking. Yeah, finally getting all that to work, except like I said before with the problem of burning out the boards, which hopefully I'm going to get that fixed now with your guys' advice.
Cool.
Yeah.
Yeah, so we had another session after it turned out that Jack was having issues last week. We had another session, just a couple of us and Jack, and we got some ideas on how to manage the power. But hey, back on your robot there, Jack, it looks kind of cool. Is that the Adafruit 24 LED ring that happens to fit exactly perfectly on the LiDAR?
Yeah, I did have to sand it down just a little bit on the inside.
A little bit of foul to fit, huh?
But it ended up fitting. Yeah, and it spins pretty smoothly, so that's nice.
That's pretty cool.
Thanks.
A new touch. We don't have any in the club like that yet, so that'll be you'll get the Bling Award.
Okay.
That's
I do have a light show program that I'm working on for once it's finished.
Oh, cool. Maybe next week then, huh?
Yeah.
Okay, cool. All right. So next on the list, Murray, maybe just a word about yourself and that wild project you got started.
Yeah. I've been in New Zealand. I used to live in California. I'm originally Canadian, and I've been in New Zealand since 2006. And I hadn't done any robotics for many years. I actually had a high school robot project back in 1979. And of course, things have come a long way since then. So I was kind of tooling around with Raspberry Pis, and at some point I decided to try a robot project. And then as long a story as I can make short is I was talking and showing a little robot I was working on to one of our neighbors. And I live in a little town of about, I don't know, I think it's about 600 houses on about half an hour north of Wellington. And they have 2 daughters, and Ellie's the 9-year-old, and she got really enthusiastic about the robots and was even thinking about building one. And she's incredibly smart. And I thought, And her dad was thinking that, well, she's in the Cub Scouts. If I presented to the Cub Scouts, and one thing led to another, and decided to start a Pukerua Bay Robot Club. But then when I went to get the domain name for it, turns out robots.org.nz is available. So now I've got a New Zealand-wide website. So effectively I haven't mentioned this before, but once we get going, if we can ever get going, I was thinking of maybe having the DPRG and the New Zealand group be sister organizations in some form. Anybody in the DPRG could have a password onto the wiki or something like that, because I'm trying to accumulate data and resources and ideas for basically for anybody in the area, but of course it would be for anybody who can get to the site. So, but the robot that I'm working on is kind of inspired by David Anderson's SR04, and I don't know if you can see this. It's not quite.
Oh yeah, look at that.
Yeah, so it weighs about 5 kilograms. It's got a big Makita battery as its power source. It used to have a USB output on the battery, but that blew the other day. So right now I'm just using an extra battery, but I'll have a a 5-volt regulator power supply hopefully in the post at some point, and it'll actually be a single battery power supply. But I've been invited, thank you very much, to do a presentation on this robot on the 11th of April. So I won't go into too much detail, but it's kind of got everything on it at this point, more than I can program. One of my goals was, I've been a Java programmer since the 90s and professionally, and I'd never really spent much time with Python. So I've been basically using this project as a means to learn Python. So I'm actually writing a Python-based operating system. And I'll probably post it on GitHub, although I probably need some help from somebody because I have a GitHub account, but I've never really used it outside of a professional capacity. But I'd be happy to share the OS. At this point, it's multitasking. It's kind of it's inspired by a lot of the David Brooks. Is David Brooks, is it?
David Anderson.
No. Well, there's David Anderson, but there's also the guy, Rodney Brooks from MIT.
Brooks.
A lot of his ideas about subsumption architecture and things like that. So basically trying to take all this stuff in and build something, and that's what this project's turned into. So, but as I said, I'll try to do some kind of a presentation in a couple weeks on the robot and come together with actually what it's trying to do. So that's and thanks again for the invite. I appreciate being able.
Yeah, no, cool. Thanks for it's cool to have this kind of across the planets thing going on. And I mean, I had mentioned this on the side to some of the other club members, but especially now that the Texas governor and the president have extended the distancing thing through April around here. I had bet that we're not going to be able to get a makerspace and have a physical meeting. So for those of you on the call, I asked if Murray would be interested to present on his robot in our monthly meeting on Saturday the 11th, and Murray's accepted that invitation. So thank you very much.
Oh, I'm quite happy to.
And then we'll work out offline the time. I don't know if you want to be up at 6 in the morning, which was when we normally hold it, I think, or if we would do it a little bit later for you, that we can arrange that too.
I can do 6 in the morning. It's not too
So I'll chat amongst the guys offline. We'll see if we can't slide a little bit. I think with everybody stuck at home, it won't really matter when. But
we're only 6 hours different from New Zealand.
6 hours in a day.
In the day.
Oh, in a day, yeah. Okay.
18 hours ahead of us.
Okay.
It's tomorrow.
Yeah, I live in the tomorrow.
It's in the world of tomorrow. Okay, well, thanks, Murray. So, Patrick, maybe a few words about yourself and your projects right now.
Hey, everybody. It's good to see you all again.
Yeah.
It's been a while, but that's because I've been doing robots so much.
Yeah.
Been too busy to meet. As many of you know, I lead a lot of FIRST teams and do a lot of work with FIRST Robotics. And so this is normally the height of our competition season. In fact, today, if it weren't for the virus, I would be on my way to San Antonio to be refereeing at the Texas District Championship in San Antonio.
Wow.
But
That's awesome.
But that whole season got canceled 2 weeks ago.
Yeah, we got one in Plano up here. I do some mentoring on the FIRST Robotics team up here too, and they got one shot at it, and and then they got all postponed and canceled.
I was the head referee for that event.
Oh, awesome! I'll look for you next time because I know I'll be there next year.
I was wearing the yellow shirt. I was wearing the yellow shirt over by the scoring table for that. So now that all the events have been canceled and my team had made it to the World Championship, but it's been canceled. So we're no longer meeting as a team because we're practicing all the social distancing stuff. So I actually have some time to work on some of my own projects. And I saw that this was going on, so I was glad to be able to join. I don't have any current robot builds. One of these evenings or one of these days, if you all would like, I'm going to see if I can get my team members to join briefly and let them tell you some of the stuff that they've been doing with their robot. It's pretty impressive. I know you all had a presentation from Iron Rain back in February.
Yes.
But my personal team's robot is by far the #1 robot in Texas, and it was ranked #4 in the world.
Oh, wow.
So it's so I have some videos I can share and things like that. They're using a package which Iron Rain I think may have referenced. They're using a package called Roadrunner, which does navigation using odometry wheels on the bottom of the robot, and it's able to automatically correct if anything knocks it off course.
Wow.
Yeah.
So they added a bunch of capabilities to their robot. They haven't lost a match since November. They've played in about 40 matches. They haven't lost a match since November. You know, they're doing a lot of stuff with vision processing, things like that. Their goal from day one was to win the world championship. Me personally, I'm working on some small robots. I'm fixing up my house environment. The team meets at my house a lot, so I have a lot of equipment. But I'm getting the CNC machine upgraded so that I can do some more of my own builds. I bought me a new 3D printer this week and put it together. So I've been working on the one-off, the one level up from building the robot, which is building all the stuff you need to build a robot.
All the tools. Yeah.
Yeah, getting all the
Living the
tools and
dream.
everything update.
And then you realize who needs a robot? All you need is the tools.
Exactly. So anyway, it's good to see y'all, and good to see what
Yeah.
everybody's up to. And in future weeks, I will try and see if I have anything to present.
Thanks. Yeah. Let's stay in tune and get you all on the calendar at some point.
Okay.
Cool. Thanks. So Ray, how's it going out in the boonies? What you got going on?
Oh, it's doing pretty good. I fired up my the Max Pi, the SciP board, and Doug, it's good that you finally got yours. It's a long time coming.
Yeah.
Anyway, so the SciP is similar. I think I don't know. This one had Wi-Fi. You could get it without Wi-Fi. I think Wi-Fi was like $2 more. I think it was either 37 or 39, so just under $40. It comes with a pretty good size. I guess I should probably click the present thing, right? To show you.
Yeah, if you want to show us.
Okay.
We can look in the reflection in your glasses, but
Oh, can you? Okay.
it's better if you show.
Present now. Let's see. My entire screen, a window. Oh, I don't like that. Okay, I'll do the whole screen. Present now. Your entire screen. Share. Okay. Yeah, something's not working right. That's weird. I don't know if you can see this thing or not. It's pretty small.
Yeah, that's all right. Sure.
Okay. That's the front of it. And that's the LCD on the backside. And so it, you can fold it around so you can actually see, what the camera is seeing on, kind of like that. So one of the things that it's a demo Find Green Blob program, and see if I can get this to show up. Okay. Can you see my screen?
No.
No. Okay. So what I'm going to do is fold this down. Okay, so I don't know if this is going to get like multiple images on images.
That's all right.
Here.
Yeah.
But it's actually looking at the screen and it's looking for a green blob. I think if I shine it over at the green blob, whoops, my little 3D printing just fell apart. Yeah. I don't know if you can see it on the, whoops. God, this is crude. Okay, let's see if I can snap this back together. I think I folded it wrong.
When I worked at Nokia, we would call this the demo effect, Ray.
God, yeah. Let's see here.
There you go.
Okay. So
Yeah.
I don't know if you can see it. There's a green blob in the image that I have just off to the side of the desk, and it's finding that and highlighting it.
It's a bounding box around it?
Yeah, there's a bounding box. It's a pretty good sized box. Can you see that? Or
Yeah. Oh, yeah.
Mm-hmm.
okay. So it's the OpenMV H7 has an IDE, and this has its own IDE. They look very similar. I mean, some of the icons look a little bit different, but not that much different. You know, to do things, and you can the OpenMV H7 has probably, I didn't count them all, somewhere between 100 and 200 example programs of things that you can do. And this has some, but, you know, very few. I mean, maybe, I don't know, I think I could find 10 of them. So it's, you know, you can actually take the OpenMV H7 files and bring them into the IDE for this board, the, you know, SciP board. And, you know, with just a few minor modifications, you know, like one, you have to turn the camera sensor on, but they'll run. So that's kind of nice. I don't know. You can look at the SciP stuff. The IDE is nice. You can kind of like on the OpenMV H7 IDE, you can see what the camera sees on your computer screen. You can edit, you know, make changes in files. It's all in Python. So, you know, both cameras are, you know, work in Python. So you can, you know, make changes very quickly, you know, do quick experiments, that kind of thing. I don't know. I'd be curious to find out if the Husky lens would work with that. And I heard that Husky lens doesn't have an IDE. So that might be, I really like the OpenMV H7 IDE, and the fact that the SciP one is similar. You know, I thought you might like that too, as far as being able to edit files and, you know, load files from other sources and all that kind of stuff.
Well, you can, Ray, you can do that. I mean, you can bring in files, but, you know, you can see that the way they picture you using it is like a Pixie. Otherwise, pretty much a closed 5-trick pony. Basically, that's what they're seeing it as.
Oh, really? Okay.
Yeah. No, I mean, you know, I just got it like yesterday, so I really haven't had a chance. My first thought was I was going to put it on a line follower robot and let it start capturing lines and see if it can do sort of a donkey car type thing.
Ooh, that'd be
we'll just see, you know what I mean?
Yeah.
And but you know, it you know, face recognition works real well. I was able to put, for example, one of our competition cans and also just a Diet Coke can. You train it on the two. You train it on one image, and it would recognize both cans.
Oh, that's cool.
So it's truly it's more dimensional than just a blob sensor.
Oh yeah,
yeah. So I really haven't played too much with it, but you can see that they're making a really honest effort to get it documented, because something like this is extremely complex.
Oh yeah.
But you know, it's got a little bit of, you know, made in China issue, you know, in the sense that they'll say something in a way and you have to think there for a little bit, like, well, what are they really saying?
Yeah.
And what
does that mean? Yeah.
Well, let me put it this way. Here's my thought. If you get the one with the folding screen, right, for less than $40, and I mean, I don't know. Now you got to be honest here. Is that for the folding screen? I'm sure cost you some extra money.
No, well, I 3D printed the little case.
Okay.
Yeah.
All right. But I'm saying, well, that's a good point. Maybe that might be doable with this too. I'll have to check, But that is a really nice feature because, you know, it's like what God, Jack is doing, you know, where you can actually see what real time where the LiDAR is doing what it's doing.
Right.
It would be really nice to know what it's looking at and what decision
Yeah.
it's making.
Well,
By the way,
Doug
Yeah.
and Ray, I've had one of these cameras for a couple weeks now, and
Oh, okay.
I've also got a Pixie. And to me, the biggest difference, as you guys have alluded to, like in the last meeting as well, is that the Pixie is very much a Carnegie Mellon project, and it's got tons of documentation. And
Right.
you know, watching the line fall over, and they had that video of it following a ping pong ball, and I've got it, and it does exactly that. It's pretty impressive in how the servos integrate with it. The one thing about this one is it's got the little screen on the back, and
Right.
you know, you can actually see what it sees really clearly.
Yep.
But I can't find any documentation on how to find out. Like it says, I'm looking over here, it finds the chair, but how to find out where the chair is in the XY grid there, and how to get that out of the device. I'll give up. It's a nice little toy at this point until they can get some documentation. I'll be using Pixie.
Well, on that, what you're supposed to do is most of the features have a click and train feature to it.
Right.
So see, that's what I'm saying. They're not really anticipating you doing major firmware updates. What they're really showing you doing is you got a 5-trick pony here, as opposed to the Pixie, which is a 2-trick pony. And if you're doing one of those 5 things, it cuts through a lot of crap and gets you there very quick. Now, what Ray's saying with the OpenMV is you have more access to the actual firmware or example code. So otherwise, this guy, you know, he probably put something like, I see an object at coordinates X, Y. And I would assume the OpenMV, you can make it, you could probably even change the model in it if you wanted to. But this thing's supposed to be very fast for AI applications.
Right.
So
It's extremely fast.
the OpenMV doesn't have that chip, right? This new product that you're using, Ray, has got it.
Yeah. The OpenMV H7 is
It's just a camera, right?
well, I think Quavino was saying that you can do some AI stuff on it, and I think he had a mobile net demonstration, just like these have, kind of, you know, the equivalent of they have a mobile net, like one YOLO example, one you know,
Movidius level
example. But this has all the, you know, the same ports that the OpenMV H7 has. It has SPI, UART, I2C. So you could actually, you know, send, like, you know, XY coordinates if you want of an object.
Yeah.
If it'll provide it for you.
Well, that's what this is what the Husky lens probably would do.
Right, because
Yeah.
you know, identification is one thing, location is another.
So cool.
Yeah.
So yeah,
Yeah.
so they're kind of neat. I think if you really just wanted, you know, talking about the ultimate cheapest solution, you could probably get one of the ESP32s with a camera. It wouldn't have a display on it, but they've gotten those to do like the I think it's called Stack M5 or M5, no, M5 Stack, I guess. I don't know if anybody's seen those, but you can do facial recognition on those. So, you know, I imagine you can do similar things. And they're, I think they're probably less than half the cost of either the Husky lens or the SidePeep version. So you could get, you know, something that'll do maybe 20 frames per second for probably under $20 if you really wanted to do, you know, like blob detection or, you know, object recognition, that kind of thing.
Well, you know,
That's cool. So let's.
Yeah. Go ahead.
Yeah. I was going to say let's stick to what we are working on, and then because we got I'm afraid we might run out of time if we get too deep.
Okay. The other thing, can I just one more minute.
Yeah.
I've had a robot in my office. It's a robot lawnmower, and I had an issue with the battery. One of the cells in it had died, and let's see if I can.
You're mowing your carpet?
Let's see here. Yeah, it's actually a gas mower, push mower. Let's see, it's hard to tell, but I can't really see it. You can see it there. Anyway, I had 2 toy motors on the back from a ride-on toy. And it's powerful enough to push it up, even a slight grade. This one's like a 20-inch mower, and it's just like I think a 3.5 or so horsepower motor. And I'm just using a riding lawnmower battery, 12 volts, and a Mega, and one of the Polulu drivers, and got it. So I don't know if you'll be able to smell it. It'd be probably almost impossible for me to show it, but I got it so it tracks, a can. And what I was going to do is have 2 basically like traffic cones on a platform, and have this basically bouncing back and forth between the 2, kind of as the simplest method to guide a mower.
Yeah.
So it would come up to the one, and based on the size of the blob, would stop and turn around and look for the other one. In the meantime, the one that it just came close to would move forward like 1 row for mowing, and then it would, once it gets to the other one, it would tell it to move. It would turn around and tell it to move forward and look for the other one. So basically, it would be going, back and forth between 2 other platforms that just had a cone sitting on it, and then it's just moving 1 row forward each time.
Sounds like you need 3 robots then. 1 to do the mowing and 2 to move the cones.
That's right, yeah. I do have the GPS set up from SparkFun. I think that'll get you to under 1 inch accuracy, but I haven't played with those yet. So
Cool. Maybe next time you can give us a report.
Yep. Okay. Anyway, so over to whoever's next. Whoops.
Cool. Thanks. All right. That's awesome. So, Sandy, welcome. I don't know if this is your first time or not, but if there's any kind of project you're working on in Corona Apocalypse here, you're welcome to share if you like, or if not, that's fine too.
Microphone's off, I think.
Is it off? Oh, there we go. No? Huh. Microphone's off. How do we get you unmuted? Uh-oh.
Can we select? I guess we can only select our own microphone, right?
If we were to be lip readers, there, try to say something else, Sandy. When you hit your button, it was toggling the microphone icon. It's like now you're muted, now you're unmuted. Oh, that's too bad. Hey, if you'd like, Sandy, we can practice offline, and then if you want to join next week, we can get the controls worked out. So just Slack me or something, or text me or something, we'll get it going.
I suspect it's not Hangouts that's muting; it's the operating system mute.
Yeah, the OS or the laptop
on the microphone.
The microphone itself, maybe.
Oh, yeah. Huh.
These things have so many buttons in serial.
Oh, hey, Carl, have you figured out a way? Oh, I saw somebody.
No luck. Sorry, Sandy. Anyhow, welcome. Hey, just start, if you want to keep it. Hello?
Not working.
Yeah, it is.
Yeah, it is.
There it is. You say something. Your voice came out a moment ago.
Yeah, it's working. It's working great. We heard you.
Oh well.
Okay. Well, I'll tell you what. Let's work that offline, Sandy. We'll have you back next time. Hear what you're up to. So, or if you get it working, just interject and we'll bounce over. So, Will, welcome, Will. Got you online. Are you have any projects going on here in quarantine, or you want to just listen in? Okay, Will, I guess you're still on mute. So if you get unmute, then just jump in. Otherwise, let's just keep moving on. So we have about 15 minutes left, and I bet Clay has 10 or 15 minutes, and I know I have 10 or 15 minutes. So if everybody's good, we'll probably just plan on running over a little bit. If not, then speak up and we can defer things to later. But Clay, would you like to go describe what you've got and hit those topics that you had listed out there?
Okay, can you hear me?
Yep, and we can see you.
Okay, I'm working on a lot of things, but I had a couple just real quick things I could present. So let me see if this present thing here works. I'm trying to share this screen for my Raspberry Pi.
And
Yeah.
Okay, can you all see that?
Yeah.
Okay, because I can't see when it's sharing. I just see the direct screen. So I'm remotely logged into my robot. I should have showed you a picture, but most of you local people anyway have seen it. I've been working on it for quite a while for line following. I'm making a lot of improvements to it since I have a lot of time. I was recently laid off also. I'll mention that. So if you're not connected with me on LinkedIn, please connect. And if you are on LinkedIn, please endorse me for robotics or firmware, embedded systems, programming, anything. And if you know of any jobs in firmware or embedded systems, please contact me. So what I've been working on my robot, it uses a camera and a Raspberry Pi. It looks at the line and it takes a frame and decides where to steer. Well, I decided to, after I take a frame, to save it. So at first I saved that to the SD card, and that worked, but it was a little speed limited. So I got a faster SD card, and that helped. The other thing that helped was saving instead of a BMP, which is uncompressed, which is what I really want to save. I switched to saving a JPEG, which is significantly smaller, so I could save 30 frames a second or even more now. And the other thing I did is I made a RAM disk. So if I look at my mount directory, there's a directory called RAM disk that I created. And so if you can see this, there's a bunch of frames here. So I ran it for just a few seconds. It captures about 30 frames per second. So I don't know, looks like we did about 10 seconds worth of a run. And then after the run, I have a program here that's a viewer. So if you can see this, it's telling me I'm basically on frame 1. And as I push the up arrow key, and I'll just hold the key down, you can see it, and hopefully you guys are seeing this.
Oh yeah, it looks good.
So this is it going through the course. This is the gap S curve, and the little red X crosshairs, if you can see that, is where it's steering. And if you can see the background screen also scrolling by, you can see what frame it's on. I can actually go backward as well. So those are just all the saved frames of a short run. And so the other thing that I just did recently, which is pretty cool, I wrote this little script. Well, I wrote two. I'll show you the first one. Archive run. All this does is it creates a tar file of all those frames. And I did that so I can pull it off the Raspberry Pi to my desktop. And I was originally making a movie there, but I realized I could also get the Raspberry Pi to make a movie. So there's this script I have here, and this is the script to make a movie out of it. You'll see it uses this command ffmpeg, which I believe is built in on the standard Raspbian installation. I don't think I had to install that. And you just give it a path to all the frames, and then you tell it the output encoder that you want it to convert to, and the name of the output file. So I've already done that. And so here, oops, popped it up twice. There's a short video. Let me navigate to the right directory here. And here's the video, robot run 331, and that's the time, MP4. So here you can see at about real time, the video of the run that I just showed you. So I thought that was pretty cool that my robot can capture all those frames and make a little video of the run that it just did.
Clayton, one of the things that I found was that I ended up swapping out so that I've got an SD card for the boot partition, but I'm actually using an SSD for my main drive, which gives you quite a lot better performance than using an SD card.
Yes, someone else had mentioned that to me, and I thought of that also. I haven't tried that yet. I did use the RAM disk. I switched to a Raspberry Pi 4, which has even more memory, but the RAM disk is extremely fast, so that's working. Although saving as a JPEG, I'm pretty sure I could go back to the SD card now. I haven't tried that, but I'm pretty sure that would work as well. In theory, it should work because a camcorder uses those SD cards. So I have been able to go beyond 30 frames per second. I switched the camera from a webcam to the Raspberry Pi cam, and I've tested it at 45, 60, and even 90 frames per second. So I can record very, very fast. So that's about all I had for that topic. I have a couple other real quick topics. One of the topics that I was working on, I showed Carl this, is this viewer. What I want to do, it's more of a curiosity kind of thing, but I want to do basically a robot survey, so to speak. I have this little application that shows these images to a user, a human. And then what I want to do is say to the human, where would you steer? So for each little picture, and I'd show a variety of pictures, I would ask, where would you adjust the steering wheel if you were the robot driving? And I'm very curious because I'm seeing, a lot of getting this to work correctly is the steering algorithm or tuning. When I see this, how hard do I steer? Those kind of things. And one of the things I'm working on right now is it does go through this S-gap, S-curve, but it's incredibly jerky. You can actually see it basically hop from segment to segment to segment. So that's the next thing I'm working on, is putting some smoothing in there, some, basically the precursor path planning to smooth that out so it's not so jerky through that. But what I'd like to do is have this little application where users can tell me where they would steer, because I'm curious to see some of the odd cases that I have difficulty with in code where people think they would steer. And I have one other thing that I just encountered, which is I have a friend who is a ham radio buff, and they use some Raspberry Pi cameras on some of the radio towers. And he told me he did this thing where he mounts each of the Raspberry Pis as a directory on his home computer, and they're online all the time. And so I tried this out myself. I don't know if I can share it because I have to show you two screens, but I have another Raspberry Pi, and on one of the Raspberry Pis, I've created a mount point, and it's actually a directory on the other Raspberry Pi. There's this command called SSHFS. It's a secure remote file system. It uses SSH to basically mount a remote file point. So I just wanted to mention that. I won't go into it. I can pass a link. It was very easy to set up, actually. But I thought that was pretty neat to be able to have a remote directory mounted from one Raspberry Pi to another.
Pretty cool. Yeah.
And I quit sharing. I'll show my robot now that I've got the camera. Most of you have seen this. I can't see my picture, but it's just a little simple platform. It's got a battery, a Raspberry Pi, motor controller, and I switched to the Raspberry Pi camera. And I'm hoping to get that going through the advanced course and then on to the challenge course.
Cool. So when we have those physical competitions again, you're gonna show us how it's done on the challenge course that no one of us have really done yet.
Well, yeah, I've tried and failed several times, and every time I think I've made progress, I haven't really done that well in competition. So I really have the goal to, work on that. So I've gone back and basically fixed all the things that have haunted me and stepped back and restructured my code and getting things solid and getting the frame rate resolved and a lot of the things. So I'm not there yet, but I'm making good progress. And I have one other real quick thing. I'm very good at dumpster diving, so to speak. Now that I live in the neighborhood, it's seeing what people put out on trash day. And I don't know if you can see this, but I'll turn it on. It's an LED sign. And it boots up just fine. It's a multicolored LED sign that somebody threw in the trash. So it's a company that's probably out of business, but I'm going to see if I can figure out how to drive that or reverse engineer it to put a Raspberry Pi instead of this gigantic board of,
driver board
old technology to drive the thing.
Very cool.
All right, that's all I had.
Hey, thank you, Ray. Will, did you have sorry, someone? Will, did you have something you want to do, a project you're working on, or just, okay, I see a head shake. And, okay, and I guess, Sandy, if your microphone's not working, then I'll jump in. So I have a couple of things I can show the, well, I just have a couple of things. So everyone should be. Let me see if I drag this. The phone. So this guy, the kind of a thing, and control it with one of these, and basically what I intend to do with this is it's been a platform to figure out like two-dimensional translation and then rotation. So I have a kind of a hardware to software API that's pretty general purpose is my intention, and then what I can do is what I've done in the last week. Let me pull up a video and show. Let's see. Whoa. Yeah, there we go. So we have this thing called Quick Trip, right, where the robot just has to go out and come back. And since this robot has mecanum wheels, it can do it sideways as well. So it goes sideways and comes back. And then I figured there's two other variants of Quick Trip, which are new to DPRG. One is the diagonal move. So out and back diagonal. Right now, this is just using velocity loops on the PID. So I give it a little manual nudge with the control to get it to the starting point. And then I have this translate circle thing, which is in my mind. So the whole idea is that I want to use this to be able to model a hovercraft so that I can then have a kind of abstraction layer that says, you know, imagine this is like the asteroids spaceship from that game 30, 40 years ago, and it has a rear thruster, and you blast the rocket in the back, and all it does is it keeps going until you change direction and thrust it again. So now that I got the kind of basic movement under control, and I'll get the loops cleaned up a little bit, the next step is to kind of calibrate encoder ticks per distance, and then I'll work on the model to try and so that I can say I can model different styles of hovercraft. And this is just showing that, you know, I got this nice little RGB display, so I can pop a button on the controller and I can see how many encoder ticks did I get in that last self-driving routine. All I have to do is click that button, and it toggles between the current velocity and the encoder ticks. So that's the one kind of show and tell thing I was going to, from that point of view. And then let me see. So then I am going to show one other thing here, because we're going to get. I'm going to show some Visual Studio Code stuff, and I'm going to show you what that robot looks like. So basically, this is the other robot that I have that I'm working on. And this, from about here on down, is the club robot. So some guys in DPRG put this kit together in 2016. And then it has an Arduino Mega buried in there and a Monster Moto Shield. And then I've added this upper deck with the Raspberry Pi. And basically, this will be my other platform. It's just a differential drive kind of robot with a caster in the back. And the idea here is that the way it's designed, you can have this front plate on here and have grabbers or whatever extra sensors. But for now, I have this camera that I've stuck up on here. It's a little hard to see, but I'm just pointing down at the moment. But I'll have this camera hooked up to the Raspberry Pi. And then then that'll do computer vision. So I'll do the challenge line following course, or I'll change the switch, and then it'll run the donkey cart, the neural net to drive around. But for all that to work, it needs to have a communication path from the Pi down to the Mega. So I wrote this SPI protocol so that the Raspberry Pi is acting as a SPI master. And I have a Raspberry Pi slave down on the Mega, and then this is just showing that it's not triggered very accurately on the scope, but it's an 18-byte protocol that I have that I'll open source here at some point. But anyhow, those are the two that I'm working on and kind of parallel at the moment. And what I'm going to show now is some tricks in Visual Studio Code. So you know, since I have two processors in this. This guy, the Arduino is in C++, and the Raspberry, since Donkey Car, is in Python. And I don't know Python, so what better way to learn than to try and do it? So in that process, I came up with some tricks I'd like to share on Visual Studio Code. And just interrupt if anyone has any questions or anything. So basically, like last week, there's a few of us using Visual Studio Code in the club, but maybe not too many just yet. So I wanted to share some tricks that I found because it's really pretty cool what you can do with it, and it's free. The price is right. So so what I was going to cover this week was just some of the basic UI. So it's your basic IDE, and along the left side you got these icons. So you can click on here and view the different files in the project. You can see you can have folders as well, design documentation, and it has Visual Studio has plugins for PDF viewers. So it's not working today. I must have, well, I didn't give it long enough there. So it can even though it's a Git repository, it can store JPEGs and any arbitrary bitmap blob. So this is the kind of this is how this is the pin assignment, the button assignment for the controller that I use. But it's just another file to Visual Studio Code. But anyhow, so go ahead.
Carl, I was just wondering, I normally SSH into my Raspberry Pi from my desktop and do all my editing in VI or Vim on my Pi. Do you know if you can use Visual Studio Code on your desktop to modify code via SSH?
That's exactly the right question, and that's an amazing segue because that's part 2 of my demo.
Okay, good.
I'll show it working for you. Yeah, and it works like a champ.
Cool.
It basically uses the same.
If Carl wasn't going to show you, I was going to say you bet you're whatever and be vulgar. But thanks for going to show us.
Cool. Thanks.
Harold, see, there's always somebody from Microsoft on the line to keep me honest.
Yeah.
Somebody does this for a living.
Yeah, it does everything. In fact, I will tell you right now that this is probably one of the up-and-come #1 editors in all of my development people that I see. It does JavaScript really well. It does everything, and whether it's a Mac, a PC, a Linux box, doesn't really care. It really works well. Another thing, it's getting a lot of love from the open source folks. It really is.
Yeah, and it's got a pretty easy learning curve, and it's fast, and it's really extensible. So in last week I had some links on just basic like my favorite extensions and such, but this week I was going to just show some basic buttons. So this is a search window. You can search this way, and it'll search for that across all the projects. So you can see in the calibration.h if I search for encoder position right rear, here's where it's declared there, and here it's a argument, and then in the usage in the CPP file, there it is again. So it's really pretty handy, and if you click this button, you can go replace it with something else, right? Which I'm not going to do, or I could, but I could undo it with Git, but I'm not going to do it now. So so it's got global replace, but that's the old school global replace, right? Suppose you wanted to refactor something. So suppose you're in here and you wanted to call this calibrate pivot. You wanted to call that super magic of goodness, right? So you click that button, and where did it happen? It's supposed to, where did I do that? So you rename the symbol. Hello world, goodness. Definition, because it's a define. So drive calibration. Rename that to be hello goodness. And there, I've just screwed up my entire project. But it's renamed by symbols, right, instead of the comments. And of course, like we were showing last week, if it go ahead and would save it, then this next button down here, Git, would highlight that change. So, if I click on this file, it shows Git shows the difference. So there's where it was, and here's the new value. And it highlights nicely all the different places where it changed it. Oh my goodness, that's a lot. And since I don't like that, I can go back here and I can say discard all changes. And now, thanks to the magic of Visual Studio Code and Git, it's exactly back the way I started. This is the debugging, which I don't know how to use very much yet. These are extensions, which we talked a little bit about last week. You can find my list of favorite ones. Let's see, there's another, before I go down to this button, I'm going to show you, all these nice color things here. So what's really cool is that, you can see that it has context and language aware things. So actually, if you do Control plus, you can make the font bigger. Control minus, you can make the font smaller. But here, like you can see a class, it's got as green. And you can see these methods are yellow. And types and such are blue, or variables are light blue. If you're buried in the middle of something, you can like go in here and you can say, show me all of the references for that. And it pulls up all the different file locations and you just tap on it. So it makes it real easy to thread through your project if you're trying to figure out where variables are used and how it's all wired up. Refactor. Okay, so then there's a pretty format. So like let's say that you're one of these people who get all mixed up on tabs and spaces, right? That old argument, tabs versus spaces. So if you get rid of that, so it's simpler. So watch this area right here and watch what happens when I hit Alt-Shift-F. It just pretty prints it, right? So it cleans it all up. That's pretty handy. And then there's another thing that's kind of cool. So there's an organizer. Let's see, how do we get, here you go, outline. Yeah, so down on the left-hand side, you'll see that it's another way to view the structure of your program. So, so you can click on these variables, like, and it'll take you straight to that variable. It'll take you to these methods. So if you know what something is and you can't quite remember what file it's in, you just come on over to the outline part and click on motor get speed, and there it is, the getter. So class viewer, let's see, what's another handy thing? And then another thing is like if you do Control Shift P, it opens up a lot of the commands you can get from the text window. So like if I wanted to find all the commands related to Git, I could just start with Git. And you can say I have a couple different extensions with a lot of Git options, or Arduino. Control Shift P, Arduino, whoops. What in the world am I doing? There we go. So you can find all the different controls related to the Arduino extension. So so those are kind of handy. Any questions on those before I show you the thing that Murray brought up?
Oh, move on, move on.
Moving on it is. Okay, so let me, I don't know what I broke here, but it doesn't matter. I'm going to go to the other repo. The other repo is, okay, so one of the things, Murray, you just specified exactly what somebody wrote. So that's just-in-time delivery, right? So basically, this button right here lets you remote explore targets, and they can be SSH or WSL or containers. So you can imagine if you're someone like Harold online here and you've got Azure instances all over the planet, you can just use this to just get right into them and manage your whatever that way. So I have this laptop on the same access point as that Club Robot I showed you by the oscilloscope. So all I have to do is at this IP address, since I've already got it set up, I click on this, double click it, and hello, what's it not doing? I think I have to fix this first. Let me, I broke something. Somehow I broke something. So let me open up a fresh window maybe. Go away. Don't save. All right, fresh window. And then we click on this. Target, open that sucker up. In a new window, I guess I asked for, didn't I? And then it wants to know my password for the Pi, or SSH password, or whatever it is. I could type it straight.
No.
And voila.
Wow, I'm sold.
Here we are. So this is a Git repo that lives on that Raspberry Pi, on that robot that was off to the side. So basically, and I'll show you a kind of trick real time here. Yeah, so it's on that robot over there. And what we can see now is that you can see that the communication link is up and running. And another thing I'll do, I also have VNC running here, just because the more complexity, the better, right? It's like on soldering, the bigger the blob, the better the job. So, so here's a RNC shell into that same Raspberry Pi. So I'll stop the program that's running. And you can see that over there, the traces stopped flitting by over there. So, so now here we can go through it, and since Visual Studio Code now through SSH and this plugin is connected to that Pi, I can simplify the windows a little bit here. And what you do is you hit on Visual Studio Code, it's Alt back tab or something like that, or control back tab. It opens this terminal window. And was I going to do that? So you can see here that I'm again, it's shelled into the Raspberry Pi. So I can go to the right folder. And that's the wrong folder. It's the right folder. So now I can run the C++ version of my protocol test bed. And watch, whenever I hit return, you'll see that the protocol starts running on the oscilloscope. Oh, how's that? And then I can also test the Python version, as I ported it over. And there it is, the Python version. And that lets me just watch the different bytes that I'm transferring back and forth to make sure that, number one, that they're going, and number two, that I actually know how to parse them, which was quite a challenge, but for me.
Thanks, Carl. That's pretty cool.
Yeah, you're welcome. But at the end of the day, boy, it just rocks. It can be a little pain to set up. And then there's the compatibility issues, like the Arduino environment doesn't like the current 1.43 of Visual Studio Code. So I rolled back Visual Studio Code to 1.42 to make Arduino work. And then the extension for Remote Desktop broke, so I had to reinstall that. But the joys of complexity. But at the end of the day, I mean, here's this Visual Studio Code is pretty cool because you can do this remote stuff, Python, C, it's got language packs for everything. It's really smart about languages. And anyhow, that was the extent of the demo I was hoping to share tonight.
Does
Cool.
Visual Studio store all the code in the cloud?
No.
So if you went between computers, you'd still have it, or?
So what I've done here is you can use it to store in the cloud, okay? So for example, like I've mentioned, I use Git now, right? So so basically, again, this is the shell of onto that Raspberry Pi and that robot off on the corner there, all right?
Okay.
So even though I'm on my laptop, if I do a ls, let's get back out to the Git repo level. Where is it? It helps if you type Oh, where is it? Damn it. There we go. Okay, so you get to the right folder with the Git project. And now to answer your question, Jack, so if you do a git remote-v, you can see that I have this Raspberry Pi. The Git that's living on that Raspberry Pi is pointed up to GitHub, which means that like if I do a watch this work. Here's a demo effect. You do a git log, and let me see. So this is I think this is the most recent one right here, 498323. Okay, that commit.
Okay.
That's the active one. Now if we go to GitHub to have this ready, there's Pi Mega Spy. And we look at commits. Prove me right, prove me right. Oh, what did I do wrong? Well, anyhow, I don't know. I'm obviously not knowing what I'm looking at, but this commit right here, this unique hash of the code should match the one that I'm working on the Pi. So what I do is so the workflow is I log into my laptop, I use VS Code to shell into the Raspberry Pi. So I use the editor on my laptop to edit the files in the Raspberry Pi and save them and get them working. And then when they're working, I make a commit in Git over here, and then I push it up to the cloud. So now I have version control and backup in multiple places, and it's all very traceable.
Okay.
So there's a long-winded answer to a simple question. And I think I've been talking too long now, perhaps, but hopefully that was of some value. So now, if there's no other questions, let's see. I can stop presenting. And wow, we still have 9 people online. So
A very low dropout rate.
Yeah. So let's see. So Sandy, by any chance, has your microphone magically started to work yet? No luck. Okay, my promise to you, we'll figure that out. If you want to join next time, we'll get you going. Just send me an email via Meetup or something, and we'll connect somehow. But I guess if there's nothing else, it sounds like we'll do this again next Tuesday night, as long as everyone's interested. Yeah, Doug?
Before you leave, this is some paper trail. Okay, you're going to send me the file, this file, so I can get it up on the web, right?
Yeah, I'll send you the notes.
Do you have any notes? Anybody? Are you going to send notes too?
The recording actually stores all of our chat, so I believe the recording is the chat is visible in the same recording as the video.
Okay, that's good.
Should be.
All right.
And I have a few notes that I can share as well, like I did last week.
Mm-hmm. And I guess the third thing is let's see, next week is.
It's the first. You mean the first Tuesday?
It's the 7th, right? So the question is, April 7th, does anybody want to volunteer for a demo or anything? It might be too early for that, but I'm just throwing it out.
Yeah, no,
Yeah, I may have some recordings of a robot mower actually mowing.
Okay, that'd be cool. All right.
Yeah.
Would that be with your special GPS thing?
No, I've got the boards, but I needed a radio link between the 2 boards, and I've got some LoRa modules, but I haven't incorporated them into that yet. So you're supposed to use one as a base station and the other on a rover. Mm-hmm. One of the boards, I think they're claiming, and guys, you can correct me if I'm wrong, but I think it's 20 millimeters for the one board and 10 millimeters for the other one. So you're talking about less than an inch and less than a half an inch, as far as, you know, positioning accuracy. But they're expensive. The more accurate board is like, I think around $200 each. And
At least you don't have to pay monthly.
Well, you can use they're like reference points that people set up, but you have to be close enough to them to not, you know, to not require a base station board. But I looked and I'm not close enough to anything out here. Not enough cows, I guess, need GPS. So.
Precision ag for cows.
Yeah, so. Yeah. Maybe zero in on a certain variety of grass or something. I don't know. But yeah, so it's going to take a little while just to get it all together. And it was the modules that I bought are similar to the ones that Mr. Melbourne used. It was the same U-Blocks modules. U-Blocks is a company that makes, you know, GPS modules like that, and it's called GPS RTK if you're going to look it up on SparkFun.
Okay.
But
I'll be interested to see if that works.
That's the one that Ross Melbourne uses.
Yeah, right. He used the lower accuracy module, and the two boards that I bought are based on that same module. But you know, his setup actually had the radio link between the two, and I had to add mine because the boards don't come with that. So it was kind of an extra thing, and got them in, but haven't started playing with them yet. So.
Well, cool. So you'll have so Ray, you'll probably have something, and you know, open invitation if anybody has some. This can be your incentive. If you can get some progress on something in the next week, then just let me know a little ahead of time, and I can update the meetup, and we can make sure we block some time out, or just show up at the start of the meeting, and we'll arrange it then.
I wanted to ask: has anybody else found kind of the Android equivalent for what Carl had on his iPhone? Because that's kind of a neat feature that you're basically using your iPhone as another camera, right?
Yes. So if you look at the notes from last week, Ray, the one I use is called Reflector 3, and I believe you can also use it on Android.
Oh, you can. Okay. Oh, I thought
it's a $20 one though, $15, $18, $20 one. Okay. I do have two others that I found, and I can put the links in. I don't have much experience with them yet, but they have free versions that you can use. My quick analysis though shows like the paid one that I'm using, it has a better, in my view, it has a better encoders. The colors are better, and it's a sharper picture.
Of course.
But the free ones aren't quite as good, even though I mean, because my iPhone camera is a pretty butt-kicking camera.
Oh yeah.
So I used to use AirDroid when I had an Android phone, and it seemed to work pretty well, and it's free.
AirDroid, huh? Okay. Yeah, that'd be a neat feature. I guess the other thing I could do is plug in a USB camera and switch to that. If that doesn't work.
It's real handy. Well, the thing that's nice about the phones too is that they're, by my experience, most of the time these days, the phone cameras are so much better than the
laptop camera.
Yeah, so much better.
Oh, yeah.
And they're portable. I mean, I was walking around wireless with mine here tonight. So.
Yep. Yeah, that's pretty handy. Okay.
Cool. All right. Well, anybody else?
Nope.
All right, guys. Well, good to see you all. And maybe I'll block a little longer next time too. It seems like we keep going an hour and a half or two. So,
yeah.
But in any case, nice to chat with you all, and I hope you can stay safe and find all the toilet paper that you need.
Well, apparently the people have got enough toilet paper now. They were saying that it's actually staying on Walmart shelves for a while. At least that's what I've seen. So.
Oh, I better run out.
The wife was able to get paper towels today at the store. So.
Oh, really? Yeah. Yeah. How is are you any neighbors, relatives catch COVID yet, or?
Some friends of my daughter's are in Rockwell or something, but she's a band director, and their high school had a family that all the family caught it, and the dad died. So,
oh, yeah.
Oh.
And the rest of the family is going through with it, still recovering. But
Oh.
I don't know of anybody with friends in New York just yet. But
oh yeah, yeah, that's a pretty bad hit area.
And market research friends, even 2 weeks ago, we're talking to friends in Boston, and even at that time, they couldn't get masks. They couldn't get basic gear.
Yeah. Yeah.
Much less ventilators. So.
Yeah. Maybe Hackster will come up with here's how to make your own ventilator, or something.
Yeah.
People,
actually,
that's a little harder thing to do than you think, right?
Oh yeah.
There are open source MIT. There's a couple of groups out there that have open source projects, and Ford had one, I think, where they were using off the shelf inventory for like blower motors and things, where there's some stuff that's happening out there. I just hope it happens fast enough.
Yeah.
My uncle's actually working for Ford to try and get that to work.
Oh, good.
Ventilators and stuff.
Okay, yeah. Yeah, I think we met him, right?
Yeah.
Yeah. At your
graduation party.
Yeah.
Godspeed to him. Hopefully it works out.
Yeah, he's been really busy.
Yeah. Yeah, I was thinking it'd be better to catch it early versus late. Late you're going to be fighting for other people for ventilators.
Yeah.
Early you may actually be able to get one. So
just don't get it. Just wait until the treatments come out, which will happen before the vaccine. But
right.
Just don't get it. Don't share it.
Right. Yeah. Yeah, there was a food bank that my wife and I volunteered at, Four Corners Food Bank, and we just decided that it's really just too risky. I mean, they'd have maybe up to like 50 families come up, and some of the older people, they actually carried the portable oxygen supplies, and they definitely could use the food, but it's just too much randomness. It's like you think of all those, and it's not, it's kind of the opposite of social distancing. So we decided to, stop going for a while. So
it's a shame. It's rough times.
Yep. Yeah. Because we don't want to catch it.
No, don't catch it. Don't share it.
Yep. Okay.
Okay, y'all. Well, have a good night, and we'll catch you next week.
Okay.
Yep. Great. Thanks, Carl.
Thank you. Bye.
Bye-bye.